Hello all. Today's topic is estimation of numerical aperture of fiber. This is the first experiment for the subject Broadband Communication System by Bhagyashree Thorat. Before starting the lab, we have to understand what is the definition of numerical aperture. So the definition of numerical aperture or numerical aperture, it is the ability of fiber to guiding a light. That means if we are having a light source, okay, which is going to produce a light, and this is a channel. From this channel, light has to travel between the channel only. So this ability, or this is a measurement that can we measure how much light can guide through a fiber. This is nothing but a numerical aperture. This is a practical setup which is required. The main diagrams in this are data generator, digital signal transmitter, and power supply. This is the stand which is having a scale from 1 centimeter, 0 centimeter to 10 centimeter. So by moving this rod, we can change the distance from this stand 0, then 1, then 2, then 3, then 4, 5, 6. Okay. By using this, we can have a source. This is our source. LED, entire driving circuitry. Okay. And this is your fiber. Okay. In this photo, you are saying fiber is bent, but in practical, make sure that the fiber is not bent. Okay. Just photo, I have clicked this. So remember that this is your entire fiber, and this fiber is enter in this stand from here. Okay. So this is the first circuit, data generator. Always remember, when we want to generate a data, we want two types of a data, analog and digital. Fiber optics is mainly used for digital. So we are going to produce here two signals. One is a 2 kHz CTL signal and another one is a 1 kHz CTL signal. So to perform practical, we are having a two choices. One is a 2 kHz and second signal is a 1 kHz. HC04 clock, then capacitor circuit we have used to generate simple digital circuit to generate these two signals, 2 kHz and 1 kHz. Now this is a stand where we are going to insert our fiber. Okay. Now always remember that if I am having a torch, okay, and this is a projection of my torch. Okay. This is a 0. Okay. This is my scale 0. Now if I am standing here, okay, and want to measure the projection, so what we are doing, from here to here we are measuring the angle and intensity of light, angle and intensity of light. Okay. Now, second, I'm going to measure from here. I'm going to measure from here. So always remember that this angle is a constant and projection intensity of light is a changing factor. Okay. This is the next. It is a power supply. Power supply to operate this circuit. Okay. The next and very important circuit is a digital signal transmitter. So this is we are using 660 nm LED Infineon SFH 756V. Infineon SFH 756V. Okay. By using this LED, we are going to generate the light. Okay. Here we are having two connections. One is a ground and one input from data generator. This is a data sheet for HFS 756. This is my cabinet. Okay. These are the applications: household, power electronics, optical networks, light, barriers. Okay. This is very important ratings for this practical, that operating temperature is a minus 40 plus 85. Okay. Then storage temperature range minus 40 plus 100. Junction temperature 100 degrees centigrade. Soldering temperature 260 degrees centigrade. Reverse voltage 3 volt. Forward current 50 milliampere. Surge current 1 ampere. Power dissipation 120 milliwatt. Thermal resistance 450. These are the very important ratings. That peak wavelength is a 660 nm. That's why the light is red. Okay. Spectral bandwidth 25 nm. Switching times 0.1 microsecond. Capacitance 30 picofarad. Forward voltage 2.1 volt. Okay. This datasheet is available on this alldatasheet.com web page. We completed all the important points which are required to perform the laboratory of numerical aperture. Already, how to perform numerical aperture in a lab is published on my channel Pinnacle. Don't forget to watch my channel, subscribe and share. Also, your comments are valuable for me, so don't forget to comment on this lecture. Thank you.